electric flux. What is electric flux? Electric flux electric flux phi E is defined as the electric flux is directly proportional to the number of electric field lines passing through a surface area, or electric flux phi E is defined as the dot product of E vector and area vector dA. In some book we write it as E dot A, and phi E will be EA cos theta, where theta is angle between electric field line and area vector A. Understood? What is area vector? It is defined as, let's say there is a surface with certain fixed amount of area. Area of the surface is A, and a perpendicular is drawn at the surface. So this is the perpendicular. This perpendicular at the surface is known as n vector. That is normal vector. So area vector is defined as area of the surface and normal vector n. So area vector A is area times n vector, and the direction of area vector will be same as the direction of normal. Direction of A vector is same as a direction of n cap. N cap is normal vector at the surface. If surface is open, this will be again normal vector, and if it is closed, again direction of area vector will be the direction of normal vector. In case of closed surface, normal vector will be in outward direction. Like if we have a football, then normal vector at football surface will be radially outward. It will start from the center of the sphere and it will make 90 degree to the surface in outward direction. So if you want to solve the question of electric flux, you have to remember 2 points. E is electric field, A is area through which electric field lines are passing, and theta is the angle between E and A. There are different cases for theta. But first of all, let us discuss about the unit of phi E and dimension. So what will be the unit of phi E? Unit of electric flux phi E. What is the unit of electric field E? Yes, unit of electric field E. Unit of electric field E is Newton per Coulomb, and unit of area is meter square. Cos theta is unitless. So unit of electric flux phi E will be Newton meter square per Coulomb. Understood? Let's look at different cases of angle theta. Case number 1, if this is electric field E and the surface is perpendicular to the electric field. In this case, surface is perpendicular to electric field. Since surface is perpendicular to electric field, therefore normal vector on the surface will be parallel to electric field, which means E vector and A vector will be in the same direction or in opposite direction, which means theta either will be 0 degree or theta may be 180 degree. There are two possibilities in this case, either theta will be 0 degree or 180 degree. And in this case, we know that cos theta is maximum at angle 0. That is one. So electric flux phi E will be maximum in this case, and we will write it as EA cos theta, that is 0, cos 0 is 1. So this will be E into A, which simply means electric flux passing through a surface is maximum if surface is perfectly perpendicular to the electric field lines. Second case is if this is electric field E and surface of interest is parallel to electric field. If surface is parallel to electric field lines, in that case, area vector to the surface will be perpendicular to E vector. Are you getting it? If surface is parallel to E vector, then area vector of the surface will be perpendicular to electric field. Yes or no? Okay. Next is if we want to have theta in this case, this will be 90 degree. Remember, theta is not the angle between surface and electric field. Theta is the angle between electric field E and area vector A. So in this case, if you are looking angle between electric field and surface, that will be 90 degree. But angle between electric field and area vector will be either 0 degree or 180 degree. And in formula, we are interested in angle between electric field and area vector, not the angle between electric field and surface area. So you have to be careful when you are doing the question whether the angle is between electric field and area vector or it is the angle between electric field and surface. So in this case, theta will be 90 degree. And according to theta 90 degree, we will have phi E equals to EA cos 90, which will be 0. Which means minimum possible electric flux phi E is minimum 0. And it is possible only if the surface is parallel to the electric field lines. In that case, there will be minimum possible number of electric field lines which can pass through the surface. Third point is if surface is not parallel as well as it's not perpendicular, but surface is at certain angle with electric field. So in this case, let's say this is the surface in which we are interested. And in this case, the electric field E is making certain angle theta with the surface. Electric field E is making certain angle theta with electric field E. So what will be the angle between area vector and electric field in this case? So in this case, if you are interested in theta, that is angle between electric field E and surface area A, this angle will be 90 minus alpha. Let me write it alpha in place of theta. Alpha is angle between electric field and surface, and I want to know the angle between electric field and area vector. So this will be 90 minus alpha. So in place of theta, I will have 90 minus alpha. And according to formula, this will be EA cos theta, which means we will have EA cos 90 minus alpha. Understood? Okay, let's take an example. First type of question may be in vector form. So let's say I have electric field E as 3I cap minus 2J cap plus 5K cap unit, whatever be the unit, Newton per coulomb, or if it is in another unit. Then we have surface area S vector. And this surface area S vector is given to us in vector form I plus J minus K unit. And I am interested in phi E. What will be the value of phi E? Because both the quantities are given in vector form, so we can use the definition of phi E in vector form. What is the formula for phi E in vector form? It's E dot A. That is electric field vector dot with area vector. So do you know how to dot two vectors? Yes or no? Do you know how to dot two vectors?
Yes.
बोल दो भाई.
Yes, sir.
Yes, sir.
Okay. If you want to dot two vectors, what we do is we simply multiply the I component with I component, J component with J component, and K component with K component. So according to it, phi E will be 3 into 1, 3, minus 2 into 1, minus 2, and 5 with minus 1 will be minus 5. So this will be 3 minus 7, that is minus 4. So electric flux phi E is minus 4. Understood? Now, second type of question will be in terms of magnitude. Let's say there is a surface, with area 10 meter square. There is a surface with area 10 meter square, and it is placed at an angle of 30 degree with electric field E of magnitude, let's say magnitude is 10 unit, of magnitude 10 Newton per Coulomb. What is electric flux through the surface? So if you will read the question carefully, you will clearly understood that area is given to us 10 meter square. Electric field E in terms of magnitude is also we have 10 Newton per Coulomb. And to find out phi E, we have EA cos theta. So two information is clearly we have E and A. Now we are interested in angle theta. So what is angle theta? Angle theta is the angle between electric field E and area vector A. But in the question, if you will look at the angle, this is the angle between electric field and surface, right? Surface is placed at an angle of 30 degree with electric field, which means angle between surface and electric field is given to us, that is 30 degree. But we are not interested in angle between surface area and electric fielding. We are interested in angle between area vector and electric field. And I already told you, if you know the angle between electric field and surface, you can find out angle between electric field E and area by 90 minus. So in this case, angle between electric field and area vector can be given as 90 minus 30, which will be 60 degree. Now we have all the information, we can simply put it into the formula. This will be EA cos theta. The value of E is what? 10. Value of A is again 10. And cos theta. Theta is 60 degree. So this will be 100 times. Cos 60 is how much? 1 by 2. So this will be 50. And if you are interested in unit, its unit will be Newton meter square per Coulomb. Understood? Or do you have any doubt?
Sir, doubt.
Yes.
Sir, I have doubt in the angle. Means how can we find the angle between surface and electric field and
Angle between surface
surface
and electric
electric field
field.
and area?
Okay. Angle between surface area and electric field will be given into the question. And if you want to have angle between electric field and area vector, what you have to do is that just subtract it from 90 degree. That's the trick. I cannot show you here because it's not visible. It will be in 3D. If you will imagine a surface in which electric field lines are making certain angle theta, and there is another vector a vector which is perpendicular to the surface, you can look at it in this way. Let's say this is a surface, and this is area vector or normal vector at the surface, which makes 90 degree, and electric field lines are going like this through the surface. These are the electric field lines which are going through the surface. Now इसका लोक मालूम है किसी को, बुला के लेके आओ। पासवर्ड नहीं है ना, ये है, चल गया चल गया चल गया। Let's say area vector A and electric field E is given to us, and in this case अब देखो हुआ, okay. So if this angle is given to us, angle between electric field and surface, this angle is, let's say, alpha, right? And we have to find out angle between electric field and area. So this will be the angle between electric field and area. Let's say this is theta. Now if you will notice at it, this will be theta plus alpha is 90 degree, because this complete angle will be 90 degree. So from here theta will be 90 minus alpha. This is all in 3D. Are you getting it or any doubt?
Yes, sir, doubt.
Yes.
Sir, doubt clear. No problem.
Important point is, if you are given with an angle between surface area and electric field, just subtract it from 90 degree. कुछ नहीं, लॉक हो गया था, नहीं कर पाते। Understood?
Yes, sir.
Okay, next point is Gauss theorem in electrostatics. Gauss theorem in electrostatics. Anyone remember it? What is it? Gauss theorem in electrostatics states that electric flux passing through a closed surface can be given by surface integral of E dot ds, which is equivalent to net charge inside the surface divided by epsilon naught. So according to Gauss's theorem, the electric flux over any closed surface is always equal to 1 upon epsilon naught times the net charge inside the surface. So it means if we have a closed surface, and in that closed surface we have different amount of charges, q1, q2, q3 and q4 and so on, then net charge inside the surface will be summation qi, I from 1 to n. Remember, when you will find the net charge inside the surface, you will have to remember the property of charge additivity, which states that if you want to add different charges, you have to add them algebraically, and you have to be careful about their sign. If it is with plus sign, solve it with plus sign, and if it is with minus sign, deal it with minus sign. You cannot ignore the sign of the charge. So q net is the net charge inside the surface, and now I am interested what will be the electric flux which will pass through the surface. So this will be phi e 1 by epsilon naught times net charge inside the surface. This is Gauss's theorem. Or we can also find out electric flux phi using basic definition, line integral, sorry, surface integral of E dot ds. But this will be somewhat complex as compared to this one. So in case of irregular surfaces, we use the concept of Gauss's theorem, not we use basic definition like phi equals to E dot ds. For example, how it will work. But before that, let's remember it. If you are applying Gauss's theorem on a surface, then this surface is known as Gaussian surface. This surface is known as Gaussian surface. And before applying this theorem, you must also remember that if there is a charge outside the surface, let's say capital Q charge is outside the surface, then this charge will not be involved in the formula phi equals to Q net upon epsilon naught, which means charges which are outside the surface are not taken into the formula or into the Q net. So Q net is only for the charge which are inside the surface. So this is again important point. Outside charge is not considered in this case. And third point is, if you are taking a Gaussian surface, it has to be in such a way that no charge is on the boundary of surface Q1, Q2. So if you are selecting a Gaussian surface, remember it has to be in such a way that no charge is on the boundary of the surface. So we cannot take Q2 on boundary of the surface, which means either Q2 has to be inside the surface or Q2 has to be outside the surface. But Q2 cannot be on the surface. Understood or any doubt? Let's take an example. Let's say there is a room. There is a room, and in that room, a charge Q is placed at the center. You have to tell me what will be the electric flux passing through the room, complete room. So, because overall charge inside the room is Q, so net flux passing through the room will be Q by epsilon naught. But if I am interested in electric flux, which is passing through any one wall of the surface or any one surface of the room, so how will we find out it? Because net electric flux which is passing through the complete room is Q by epsilon naught. It means from 6 walls, or let's say 6 surfaces, gives Q by epsilon naught. So one surface will give how much? One surface will give Q by 6 epsilon naught. Understood? Are you getting it? Yes or no?
Yes, sir.
Next point, remember that if you are putting the charge at different location inside the room, for example, if it is at the center, answer will be same Q by epsilon naught. And if charge Q is at any other point inside the room, again answer will be same Q by epsilon naught. But the answer will change if charge Q is at corner. Charge Q is at corner. what will be the electric flux in this case? So in chemistry, in solid state, you are told that any atom at corner will give only 1 by 8 part of itself, which means if there is a charge at the corner, it will give only 1 by 8 to the cube and 1 by 8 to another cube which will be adjacent to this cube. So in simple words, you have to remember that if charge is at corner point, it will participate only 1 by 8 part, which means in this case, electric flux will be Q net, which is Q by 8 divided by epsilon naught. So answer will be Q by 8 epsilon naught. If the charge is at if the charge is at any surface, any one of the wall. So in this case, if charge is at, this is for corner, this is for surface. If charge is at wall, in that case, Q will give only 1 by 2 part of itself. So electric flux will be Q by 2 epsilon naught, which will pass through the surface. Third case, if charge is at any one of the side of the room, like charge is at this point, Q. So in this case, charge is at side length or edge of the cube. In this case, charge Q participates only 1 by 4th part. So electric flux phi will be Q by 4 epsilon naught. Are you getting all these cases? Yes.
Yes, sir.
Okay, next point is application of Gaussian surface or Gaussian theorem. These are standard formulae, you have to remember them. Application of Gauss theorem. First point is, let's say there is a linear charge or there is a wire of infinite length at which certain amount of charge is given Q with positive polarity or negative polarity, and this charge Q is distributed over the wire in such a way that linear charge density of wire, that is lambda, is Q by L. Lambda will be given to us, and we want to know what will be the value of electric field E at a distance R perpendicular to wire. What will be the value of E at this point? So the value of E at this point is given by E is equals to K lambda by R. Sorry, it's 1 upon 2 epsilon naught. So in terms of K, this will be K 2 lambda by R, because we have with 2 and divide with 2 to make it 1 by 4 pi epsilon naught. So electric field E will be K 2 lambda by R. If charge is positive, electric field will be outward. If charge is negative, electric field will be inward. So you have to remember this formula. What is the value of electric field due to a wire with linear charge density lambda? Second point is, if we have an infinite plane sheet with surface charge density sigma, and we want to know the value of electric field at a distance r from the plane sheet. So this formula is E equals to sigma by 2 epsilon naught. Sigma is Q by A. This is surface charge density. Remember, in this case, electric field is sigma by 2 epsilon naught. And in the formula of E, there is no involvement of R, which simply means In case of infinite plane sheet, electric field E is independent of R, which means if you are taking different points, in nearby region of the plate, let's say one point is this, one point is this, and one point is this. Similarly, here we have a point, let's say this point is P1, this point is Q1, and this point is R1. So electric field E at P will be same as electric field E at Q and will be same as electric field at R point. Interesting point is it may be experienced that charge P, sorry, point P must have greater value of electric field because it is nearby the plane sheet or it is nearby the surface as compared to point Q and point R. But this is not the true. The fact is electric field E at point P at point Q at point R will be exactly same in case of infinite plane sheet. Will it be true for all the cases, which means is it true for all the distances? The answer is no. It will be true for certain limited distance, which means like if you are in this range, E will be same at all points. But if you are going outside of this range at this point, or this point, then the value of E will change. At this point, it will be different. At this point, it will be different. And at this point, this will be different. But within the same range, if you are within the given criteria, in that case, the value of E at all points will be same. It is independent of distance to a limited distance, but after that distance, it will start changing. Understood or any doubt? Yes. Understood or any doubt?
Clear, sir.
Okay. So electrostatics is completed. Now we can focus on potential energy, electric potential, and capacitors. Before that, there is an interesting concept which is known as electric dipole.
Sir, the
What
screen
is
is not
electric
visible.
dipole? Yes,
Screen is not visible.
screen is not visible. Now,
Yes, sir, it visible right now.
okay, what is electric dipole? Electric dipole is a system of charge with equal magnitude but opposite sign. This is plus, this is minus. So this arrangement is known as electric dipole. If we have two charges with same magnitude but opposite sign and we place these two charges at a little distance, then the arrangement is known as electric dipole. For any electric dipole, we have its dipole moment. So for any electric dipole, we have dipole moment. Dipole moment is given by vector P, which is any one of the charge of the dipole because both of the charge are of equal magnitude, multiply with 2L vector. Here L vector will indicate the direction of dipole moment, and if you are in physics, the direction of dipole moment P is from negative charge to positive charge. If you are in chemistry, a direction of dipole moment is given from positive charge to negative charge. So remember this point. And dipole moment of any electric dipole is given by vector P, which is Q into 2L. Q is the charge and 2L is the distance between these two charges. In some book, it can also be written as dipole moment P is equals to charge Q into separation between them, that is D. In that case, D will be equals to 2L. Are you getting it?
Yes, sir.
What will be the unit of dipole moment? Since dipole moment is the product of charge and distance, so we will have its unit as, for charge we will have coulomb and for distance we will have meter. So unit will be coulomb meter. And if you are interested in dimensional formula, it will be what? For charge we have AT and for distance we have L. So this will be the dimension of dipole moment, which is LAT. Understood? Understood or any
Yes, sir.
doubt?
Yes, sir.
केमिस्ट्री निकाल लेंगे. In chemistry, we have completed solution. Now we will complete a simple chapter which is core chapter in chemistry. That is mole concept and stoichiometry. In mole concept, we define a quantity mole to take the number of particles of any chemical substance when we are doing calculations regarding a chemical reaction. Because in a chemical reaction, there will be millions of number of atoms if we are taking few grams of any chemical substance. So we cannot deal with them in millions. So we need a physical unit which can deal with such number of atoms or molecules. And that's why we define mole. What is 1 mole? We simply define it as 1 mole is the amount of any chemical substance which will contain 6.022 into 10 raised to power 23 particles. And when we say particles, these particles may be anything. These particles may be atoms. These particles may be ions. These particles may be molecules. Or these particles may be electron, proton, and neutrons. It will depend on the question. Right? Now, there is a relation between mole and other quantities of the chemical substance. So we define it as 1 mole is equals to 6.022 into 10 raised to power 23 particles. If you want to find out number of moles, we have formula mu equals to N equals to W by M, where W is given amount, M is molar mass, and 1 mole of any chemical substance is equal to GAM or GMM. GAM is gram atomic mass and GMM is gram molecular mass, which means if we will express atomic mass in gram, it will be equal to 1 mole. For example, we have sodium atom. If I say atomic mass of sodium, what will be your answer? Atomic mass of sodium. Yes, anyone? Atomic mass of sodium. कोई तो बता दो भाई.
Sir, 23.
23 what? 23 gram, 23 kg, 23 AMU, 23 milligram. What 23? Yes, atomic mass of sodium is what? 23 AMU. And if I say what is the molar mass of sodium, then this will be 23 gram. So if you are taking atomic mass in grams, it will work as mole, right? And if you are taking atomic mass in AMU, then it will be simply atomic mass. So again, read the question carefully. Is it gram atomic mass or it is simple atomic mass? Simple atomic mass will be in AMU, and simple atomic mass indicates the mass of one single atom, while gram atomic mass or atomic mass in gram or molar mass indicates the mass of one mole particles, that is mass of 6.022 times 10 raised to power 23 sodium atoms. This is what do we mean by gram atomic mass and gram molecular mass. In case of molecular mass, let's say we have a molecule CO2. What is the molecular mass of CO2? This is 44 AMU. And if you are looking for molar mass of CO2, we will say it will be 44 gram. So you have to be careful about the unit. Next point is, if you have any gas at 1 mole, if we have 1 mole of any gas at STP, that is standard temperature pressure, then its volume will be fixed. This will be 22.4 liter or this much ml. Liter sometimes is also given as dm cube. So dm cube and liter is same. So 1 mole of any gas at STP will have 22.4 liter, which means if I have 1 mole of oxygen at STP, 1 mole of hydrogen at STP, and 1 mole of helium at STP, all the gases will have same amount of volume, that is 22.4 liter. Are you getting it or any doubt? Yes? Okay. So now we can do some simple questions. Let's say question number 1 is, find the number of moles of 46 gram sodium. Also find number of electrons, protons and neutrons in 46 gram sodium. How will you solve it? So in the question we are given with certain amount of sodium, that is given amount 46 gram. We know the molar mass of sodium, that is 23 gram. Now we will find out number of moles n. Number of moles is given amount upon molar mass. Given amount is 46, molar mass is 23, so number of moles will be 2. This is the first part of the question. Number of moles of 46 gram sodium, that will be 2 moles. Now the question is, we want to know how many electrons, protons and neutrons are there in 46 gram sodium. Because we are having 2 mole of sodium in this case, which implies that 1 mole sodium will have Na number of atoms, where Na is Avogadro number. This quantity is given by Na. If we have 1 mole of sodium, there will be Na atoms, and in case of 2 mole, there will be 2 into Na atoms. Now look at the nuclear composition of sodium atom. Sodium Na is 1123, which implies that value of Z is 11, value of A is 23. And if you are interested in proton, this will be equals to Z, that is 11. If you are interested in electrons, this will be equals to proton, that is Z, again 11. And if you are interested in neutron, this will be A minus Z, which will be, I think, 12. Right? And this arrangement or this composition is of single sodium atom. Right? Which means if we have one sodium atom contain 11 proton, 11 electron, and 12 neutron. So how many total atoms of sodium we have? Total atoms of sodium in 46 gram we have twice of Na. So if we have twice of Na atoms of sodium, how many proton will be there? So this will be 11 into twice of Na proton, 11 into twice of Na electrons, and 12 into twice of Na neutron. So answer will be 22 proton, 22 Na proton, 22 Na electron, and 24 Na neutron. So in numerical value, if you want to have, proton will be 22 into 6.022 into 10 raised to power 23. Electrons will be same as protons, and neutrons will be 24 into 6.022 into 10 raised to power 23. Are you getting it? Yes or no? Any doubt?
No, sir.
Okay. Let's deal with another question. If we are given with 36 gram of H2O, what will be its number of moles, number of proton, number of electron, number of atom, everything we want to calculate about 36 gram of H2O. So let's say we have 36 gram of H2O, and I want to have all the information about 36 gram H2O. All the information means number of moles, number of molecules, number of atoms, number of electron, proton, and neutron. So in this case, we are given with certain amount of H2O, that is 36 gram. What is the molar mass of H2O? 18. Do you know how to find out molar mass, right? 2 into 1 plus 1 into 4 oxygen, we have 16, so this will be 18. Number of moles is given by W by M. 36 by 18 will give 2. So we have total number of moles as 2. Number of moles 2. Now in case of sodium, constituent particle is atom. So we have taken 1 mole sodium as 6.022 into 10 raised to power 23 atoms. We are not using the word molecule. But in case of H2O, constituent particle is not atom. In case of H2O compound, constituent particle is number of molecules or simply molecules. So if you will convert it into molecules, it will give you what? Number of moles is 2. 1 mole is equals to 6.022 into 10 raised to power 23 molecules. 2 mole will give you how much molecules? 2 into Na molecules. Understood? Now the question is, if we have 2 mole H2O, how many mole of hydrogen will be in 2 mole H2O? So mole of, let me write it as, we have 2 mole H2O according to the question. And now I want to know number of moles of hydrogen. Similarly, I want to know number of moles of oxygen. Anyone? How many number of moles of hydrogen will be in 2 mole H2O? So in 2 mole H2O, we have 2 H atom, which means there will be 2 into 2 moles of hydrogen. And for oxygen, we have 2 mole and 1 mole will contain 1. So this will have 2 mole oxygen. So in 2 mole H2O, we have 2 mole oxygen and 4 mole hydrogen. Now you can find out number of H atoms. Since we are having 4 mole hydrogen, since we are having number of hydrogen at 4 moles, so this will be how much? 4 into Avogadro number. That is 4 into 6.022 into 10 raised to power 23. If you are interested in number of oxygen atom, this will be how much? 2 mole. 2 mole oxygen. 2 mole oxygen, which means 2 into Avogadro number. This will be how much? 2 into 6.022 into 10 raised to power 23 O atoms. Are you getting it or any doubt? Yes? Yes or no?
Yes.
Next question is, sorry, we are having different part of the same question. So next part is number of electrons and protons and neutrons. So let us take again H2O molecule. What do you think? How many protons will be there in H2O molecule? One single molecule of H2O will contain how many protons? So number of protons is equals to atomic number of the atom. Since in H2O we are having 2 hydrogen atom and 1 oxygen atom, so number of proton will be 2 into number of proton in hydrogen atom, that is 1, because atomic number of hydrogen is 1, and 1 oxygen atom will have what atomic number oxygen have? 8. So proton will be 10. Because H2O is a neutral compound, there is no positive or negative charge for H2O. It means there will be same number of electrons as protons. So electron will be same as proton, that is again 10. What will be the number of neutrons in H2O? Because in H2O we are having one atom hydrogen and hydrogen atom has no neutrons. So there will be neutrons just because of oxygen atom. And oxygen atom is 8 or 16, which means number of neutrons in oxygen is 8. So there will be total 8 number of neutrons in one molecule of H2O. Now we can discuss total number of protons. Or let me write it as simply. Total number of protons in 2 mole H2O, because 36 gram H2O means 2 mole H2O. So number of protons in 2 mole H2O. 2 mole will contain 2 into Avogadro number of molecules of H2O. Molecules of H2O, which means 2 into Avogadro number. Molecules of H2O are there, and one molecule has 10 protons. So multiply it by 10. This will be 20 Na protons. Similarly, electrons will be 20 Na. And if you are looking for neutron, this will be how much? This will be 2 into Na into 8, which means 16 times Avogadro number. Understood or any doubt? Any doubt? Okay. So now we can discuss on the next topic in this chapter, that is stoichiometry, which is the last topic. Stoichiometry. What is stoichiometry? Stoichiometry is the calculation of one or more information from a given information regarding a chemical equation. The question will be in such a way that there is a chemical reaction with a chemical equation. Chemical equation will be balanced, and using that chemical equation, you have to extract So in stoichiometry, we will find out some information using a balanced chemical equation. Important point is the equation has to be balanced. If equation is balanced, then we can apply the concept. If it is not balanced, first we will balance it and then we will apply the concept. So let us understand from an example what is stoichiometry. Let's say we are studying about Haber process. Haber process is a process in which ammonia is formed, ammonia NH3, using a chemical reaction between hydrogen and nitrogen gas, for which equation is hydrogen H2 plus nitrogen N2, which gives ammonia NH3. First of all, check whether the equation is balanced or not. Number of nitrogen atom on left hand side or reactant side is 2, and number of nitrogen atom on product side or right hand side is 1, which clearly states that the equation is not balanced. So we have to balance it. To balance the equation, I will multiply ammonia NH3 with factor 2. Now nitrogen atom will be balanced, but hydrogen is not balanced. So to balance the hydrogen, I will multiply here 3. I hope you got it. So this is 3 nitrogen plus 3 hydrogen gas plus 1 nitrogen gas, which gives 2 nitrogen. Ammonia, sorry. So now this is the balanced chemical equation, and we can have different information using this equation. For example, if I want to know how many moles of hydrogen is used to exhaust 1 mole of nitrogen in Haber process, which means to completely react with 1 mole nitrogen, how many moles of hydrogen gas will be required? So according to the equation, this will be 3 moles. And if you are looking in terms of molecule, the same equation provides आज कुछ है क्या इतना सुधर क्यों रहे हैं लोग The same equation gives us information in terms of molecules. If I want to know how many molecules of hydrogen are needed in a Haber process for 1 molecule of nitrogen, so again answer will be 3. 1 molecule of nitrogen react with 3 molecule of hydrogen to give 2 molecule of ammonia. So the same equation gives different information in different format. It all depends on the question how we are taking the information out of the equation. So I can write it in different ways. For example, if we are having 3 mole hydrogen in Haber process, we will need 1 mole nitrogen to completely react it, and then we will have 2 mole of ammonia. Or you can write it as 3 molecule of hydrogen react with 1 molecule of nitrogen to give 2 molecule of ammonia. Or you can also write it as what is the molar mass of hydrogen? This will be 2 gram. And if we are having 3 mole of hydrogen, this will be 6 gram. So we can convert it into grams. This will be 6 gram hydrogen is needed for 14 gram nitrogen 14 gram nitrogen to produce 2 mole ammonia. 2 mole ammonia means how much gram? Ammonia had 17 as its molecular mass. So this will be 2 into 17, that is how much? CBSE वाले चले जाए भाई. This will be how much? 14, 3, 17 na? And 17 multiplied 2 will be how much? 34 gram. Which means I am taking nitrogen in wrong way. Atomic mass of n atom is 14. So molecular mass of nitrogen gas will be 28 gram. Now it will be right. 6 gram plus 28 gram will give 34 gram. Law of conservation of mass is valid. Or you can also take it in terms of volume. Like if we are using 3 mole hydrogen, this means 3 into 22.4 liter hydrogen will be used. To react with 1 mole nitrogen, 1 mole nitrogen means 1 into 22.4 liter nitrogen. And we will get 2 moles of ammonia, which means 2 into 22.4 liter ammonia. Now 22.4 liter is common factor, so we can simply cancel it. So now the information will be like this: 3 liter hydrogen react with 1 liter nitrogen to give 2 liter ammonia. Understood? So this extraction of information from a chemical equation, balanced chemical equation, is known as stoichiometry. Using the stoichiometry, you can have any other information. For example, let's say the question is, in Haber process, if we have 2 mole nitrogen, how many moles of hydrogen will be required? Since according to the stoichiometry, 1 mole of nitrogen needs 3 mole of hydrogen. So 2 mole of nitrogen will be needed for 6 moles of hydrogen. And if you are going into the question in this way, like how many moles of ammonia will be formed from 2 mole nitrogen? So again, from stoichiometry, you will get that 1 mole nitrogen gives 2 mole ammonia. So 2 moles of nitrogen will give how many moles of ammonia? 1 mole is giving 2 mole. So 2 mole give how much? Yes? Anyone? 1 mole of nitrogen gives 2 mole ammonia. If we are having 2 mole nitrogen, how many moles of ammonia will be there? No one. It's a simple question.
4.
थैंक यू. इतना जल्दी आंसर दे दिया आप लोगों ने, आपका एहसान है मेरे ऊपर. 1 mole nitrogen gives what? 2 mole ammonia, right? And we are having 2 mole nitrogen, which will give what? 4 mole of ammonia. And the same question may be in quantity form. For example, the question may be like this: how many grams of ammonia will be there if we have 2 mole nitrogen? So now there will be a relation between number of moles and quantity of ammonia. So we can write it as 1 mole nitrogen gives 2 mole ammonia. But now, according to question, I am not interested in moles. I am interested in quantity. So I will convert 2 mole into gram. And this will give how much? 2 mole. 1 mole of ammonia will have 17 gram. So this will be overall 34 gram. Now the question will be like this: if 1 mole nitrogen gives 34 gram ammonia, how many grams of ammonia will be there for 2 mole nitrogen? So 2 mole nitrogen will give how much? 2 into 34, that is 68 gram ammonia. The same question may be in liters. How many liters will be there from 2 mole nitrogen? So question will go in this way: if we have 1 mole nitrogen, we got 2 mole ammonia. 2 mole ammonia is 2 into 22.4 liter. Now the question is between mole and liter. So I will convert number of moles into liters. So 1 mole nitrogen will give 2 into 22.4 liter ammonia, and 2 mole nitrogen will give how much? 2 into 22.4. That is 4 into 22.4 liter, which means this will be how much? 4 for the 16, 8, 9, 8. 89.6 liter. Am I right? Am I right? Okay. Okay. Topic is completed. Now you can solve all the questions related to mole concept and stoichiometry. The last point in this chapter is limiting reagent. Limiting reagent is that chemical substance which will decide the rate of the chemical reaction, as well as it will decide which product will be formed in how much quantity. Which means in a chemical equation, there is a particular chemical substance or reagent according to which every information will be concluded, and that particular compound or chemical substance is known as limiting reagent. If we will talk in terms of quantity, limiting reagent is the chemical which will be consumed at first. The one which will be consumed first will be limiting reagent. Are you getting it? Let us take an example to understand the limiting reagent. Let's take a simple reaction. Carbon plus oxygen gives CO2. Is it balanced? Yes or no? Carbon atom is balanced, oxygen atom is also balanced. So the equation is balanced. Now let's say we are given 24 gram carbon and 32 gram oxygen. And the question is, in this reaction, according to the equation, which will be limiting reagent? Carbon or oxygen? Which will be limiting reagent means which chemical will be consumed first? Is it carbon or oxygen? So again, we will take the help of stoichiometry. Question is regarding limiting reagent. We are given with equation carbon plus oxygen, which gives CO2. And if we have 24 gram carbon and 32 gram oxygen, which will be limiting reagent? Which is limiting reagent? This is the question. So how will we deal with it? We have carbon with oxygen, which gives CO2. The reaction is balanced. So we will go according to the stoichiometry. And the stoichiometry of this equation tells us that 1 mole carbon will be needed for 1 mole oxygen, and 1 mole CO2 will be formed. Now, if you look at the 1 mole carbon and converts it into quantity, because we are given information for carbon and oxygen in grams. So let's convert it into gram. 1 mole carbon will have 12 gram, and 1 mole oxygen is how much? This will be 32 gram, right? Because oxygen is 8 or 16. Atomic mass of oxygen is 16, and we have 2 O atom. So this will be 32 gram oxygen, and 1 mole CO2 will have 44 gram CO2. According to question, we are not interested in CO2. We will just focus on carbon and oxygen. So according to the stoichiometry, we know that 12 gram carbon is needed for 32 gram oxygen. But we are having how much? 24 gram carbon. So for 24 gram carbon, we will need how much oxygen? In this case, 12 is doubled to get 24, right? So we will double it also because it is equality between them. According, what is equality? Equality states that there is a change in left hand side, the same change will be on right hand side. So 32 into 2 will give how much? 64 gram oxygen. So this implies that if you are having 24 gram carbon, to burn it completely, you will need 64 gram oxygen. But we have only 32 gram oxygen. So which element will be consumed first? Carbon or oxygen? Oxygen will be consumed first. Yes or no? Because we have only 32 gram oxygen and oxygen is needed how much? 64 gram. So in this question, we can clearly state that limiting reagent is oxygen. Limiting reagent is oxygen. लिमिटिंग रिएजेंट के केस में जो लिमिटिंग रिएजेंट है वही शहंशाह है, फिर सारा का सारा खेल उसी के अकॉर्डिंग चलेगा, तो यही किंग है इसमें. नाउ ऑल द कैलकुलेशन विल बी डन अकॉर्डिंग टू ऑक्सीजन, नॉट अकॉर्डिंग टू कार्बन. लेट्स से फॉर एग्जांपल द क्वेश्चन इज how many grams of CO2 will be obtained by burning 24 gram carbon with 32 gram oxygen. Since in this case oxygen is limiting reagent, so we will do the stoichiometry according to oxygen, not carbon. And what is the stoichiometry of oxygen with CO2? This is 1:1, which clearly states that if we have 1 mole oxygen, 1 mole CO2 is obtained. In grams, 32 gram oxygen will give 44 gram CO2. And we have exactly 32 gram of oxygen. So CO2 will be 44 gram. Now the question may be, if oxygen is limiting reagent, it means oxygen is consumed first and carbon will be remaining in the reaction. So question is, how much carbon is left? How much carbon is left? What is the amount of carbon that is not utilized? So now we will look at the stoichiometry of oxygen and carbon, which states that 1 mole oxygen react with 1 mole carbon. In terms of gram, it states that 32 gram oxygen react with only 12 gram carbon. And we have total carbon as 24, which clearly states that we will be left with 12 gram carbon, which is unburnt. So unburnt carbon is 12 gram. And used carbon is also 12 gram. Understood? Or any doubt in it? Yes. Any doubt? Okay. मैथ्स निकाल लेंगे. In mathematics, we have completed matrices. So we will start new chapter, that is determinants. First of all, what is determinant? We will write it as determinant is a function in which we will give input a square matrix, and for any square matrix it will give us a real number. So determinant can be considered as a function. Determinant is a function whose input will be any square matrix and whose output will be a real number, which means determinant assigned a real number to a square matrix. For a square matrix, there will always be a particular number which is known as determinant of the square matrix. Second important point is the concept of determinant is valid only for square matrix. We cannot find out the determinant of any other matrix. It is only square matrix for which we will discuss determinant. Now, next point is how to find out the determinant. So let's start with the simplest square matrix. What do you think? What is the simplest square matrix? Yes. What is the simplest square matrix?
The 2 by 2.
2 by 2. Wrong answer. Simplest possible square matrix will be a matrix with certain element A of order 1 into 1. Number of row is 1, number of column is 1. So obviously simplest square matrix is 1 into 1. Now I want to find out its determinant. So we write it in different form. In some book we write it as determinant of matrix A. In some book we write it as determinant of matrix A. Some authors write it as determinant of matrix A. Some authors write it as simply determinant, and some of them write it as this. So there are different ways to write the same information. What will be the determinant of 1 into 1 ordered matrix? The answer will be its element itself. Whether the element is positive or negative, answer will be the element. Remember, in this case, if we are writing it as determinant A, then these two bars are determinant, not modulus. So do not confuse it with modulus. It is determinant, not modulus. Understood? For example, let's say we have a matrix B with element 2, 1 into 1. And I want to know the determinant of matrix B. Some author will write it as determinant B. The answer will be 2. If we take any matrix C minus 5, 1 into 1, what will be its determinant? Determinant of matrix C or determinant of matrix C will be what? Its element, that is minus 5. This is first point. So if we are given with a matrix of 1 into 1 order, its element will be the determinant. Second point, we have a matrix with 2 into 2 order. A11, A12, A21, A22. This is a square matrix of 2 into 2 order. And we want to find out its determinant. So determinant of matrix A can be written as this one. In some book we will write it as determinant. I am again stating it. This is not modulus. This is determinant. A11, A12, A21, A22. Now what we have to do is just cross multiply. So A11 will be multiplied with A22 minus A21 will be multiplied with A12. This will be the answer. This quantity is known as determinant. It may be positive, negative, zero, rational, irrational, any number. Any real number it may be. So let's do some question. We have a matrix 2, 3, 4, 5. what will be its determinant? So determinant of matrix A will be 2, 3, 4, 5, and this will be 2 into 5, 10, minus 3 into 4, 12. Answer will be minus 2. Next, let's say we have a matrix B, which is minus 2, 3, minus 4, minus 5. Or let me write it simple 5. What will be its determinant? Yes, minus 2. Minus 2. So this will give us what? Determinant minus 2, 3, minus 4, 5, cross multiply. Now this will be minus 2 multiplied with 5. Minus 2 multiplied with 5. There will be minus sign. And then we will take 3 multiplied with minus 4. So this will give us what? Minus 2 multiplied with 5 is minus 10. Minus 3 multiplied with minus 4 is minus 12. So this will be minus 10 plus 12. So answer will be plus. Understood or any doubt? Yes. Next point is, how do we calculate the determinant for 3 into 3 matrix? So let's say A is a matrix with order 3 by 3, A11, A12, A13, A21, A22, A23, A31, A32, A33. So to find out the determinant of the given matrix A, we will write it as determinant A, A11, A12, A13, A21, A22, A23, A31, A32, A33. Now there are 3 rows and 3 columns. So there are total 6 different ways to calculate the determinant. A determinant of matrix A can be calculated by 6 different ways. 3 according to 3 different rows, according to R1, according to R2, and according to R3. And 3 ways will be according to the columns, according to column 1, according to column 2, according to column 3. So it will depend on the student how someone is expanding the determinant. Maybe someone is doing it with R1 and someone is doing it with R2, or similarly for C1 and C2. The rule for doing is that first of all you will have to decide the sign convention of the elements, which starts from plus sign. So this will be plus, minus, plus, minus, plus, minus, plus, minus, plus. Plus minus will be in alternating sense. Now we can expand it using R1, R2, R3 or C1, C2, C3. Let's say we are expanding the determinant using R1. So what will be the value of determinant A? Using R1, first element is A11. First element is A11. So we will take A11 and we will delete corresponding row and column of element A11. So element A11 had row number 1 and column number 1. So row 1 and column 1 will be deleted and we will be left with 2 into 2 order determinant, that is A22, A23, A32, A33. Next element is A12. Its convention is minus, so this will be minus A12 and we will left with the determinant. Now we will delete corresponding row of element A12 and column of A12. So we will be left with these elements. So this will be A21, A23, A31, A33. Next we have, hello, भेज देता. Okay. जेई वाले बच्चे नीचे चले जाओ, ग्राउंड फ्लोर पर बुलाया. हाँ वही नीट जेई वाले. जाओ. Now we will take third element A13. Its convention is plus, so we will have plus A13. And now we will delete corresponding row and column of A13. So this will be deleted, this will be deleted, and we will be left with A21, A21, A22, A31, A32. And now we can simplify it. So determinant A will be A11 is outside of the bracket. In bracket we will have cross multiplication of these. So this will be A22, A33 minus A32, A23. A32, A23. Now we will have A12 inside bracket. A12 with minus sign inside bracket we will have this. A21, A33 minus sign A31, A23. Bracket close. Then we have plus A13. So this will be A21, A32 minus A31, A22. Are you getting how to solve 3 by 3 matrix for determinant? Okay. Let's find out the determinant of matrix A, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So determinant A will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Convention will be plus, minus, plus, minus, plus, minus, plus, minus, plus. Or let's say we expand it using first row. So determinant A will be 1 with 1 first row and first column will be deleted. So we will have 5 into 9, that is 45, minus 8 into 6, 48. Next we have minus 2. According to minus 2, first row, second column will be deleted. And we will have 4 into 9, 36. And 7 into 6 with minus sign, that is 40. Then we will have plus 3. According to plus 3, first row, third column will be deleted. And we will have 4 into 8, 32 minus 7 into 5, 35. Simplify it, this will be how much? 45 minus 48, minus 3. 36 minus 42, minus 6, minus 6 with minus 2, plus 12. 32 minus 35, minus 3. Minus 3 into 3, minus 9. Minus 3 minus 9, minus 12 plus 12, 0. So determinant is 0. Interesting point is 1, 2, 3, 4, 5, 6, 7, 8, 9 are in AP. If the elements are in AP, determinant will be always 0. Understood? If the elements of determinants are in AP, its determinant will also be 0. For
Sir, can
example,
you
if
repeat?
I write it as, let's say B determinant is 3, 4, 5, 6, 7, 8, 9, 10, 11. What is its answer? Will be 0. Understood? Same is true for GP. If elements are in GP, determinant will be 0. So you can write it as, if elements are in AP or GP, determinant will be 0. Understood or any doubt? Yes? Okay. Now let's take some standard matrix for which we have a trick to calculate the determinant. First one is diagonal matrix. We know that diagonal matrix is a square matrix with its diagonal elements, and remaining other elements will be 0. What will be the determinant of this matrix? So determinant of this matrix will be simply multiplication of diagonal elements. Right? Determinant will be multiplication of diagonal elements, which means if you have a matrix A, let's say 1 0 0 0 3 0 0 0 minus 4, what will be its determinant? What you have to do is just multiply the diagonal element. So 1 into 3 into minus 4, answer will be minus 12. Are you getting it? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Next trick is about triangular matrices. We have two types of triangular matrices, either upper triangular or lower triangular. What is the condition for upper triangular? Elements in upper triangle will be non-zero and elements in the down triangle will be 0. So let's say there are certain elements A at the diagonal A, B and C, and some other elements are there. We want to have its determinant. So its determinant again will be A into B into C. Same is true for lower triangular matrix. This will be a lower triangular matrix A, B, C. Determinant again will be multiplication of diagonal elements. For example, if I have matrix 1, 2, 3, 0, 4, 5, 0, 0, 6, and we want to have its determinant. So what will be its determinant? For this, its determinant will be multiplication of diagonal element. 1 into 4 into 6. Answer will be 24. Same is true for lower triangular matrix. Let's say this is 2, 0, 0. This is 3, 4, 0. This is 6, 7, 8. This is lower triangular matrix. What will be its determinant? Determinant will be multiplication of diagonal element. 2 into 4 into 8. So this will be how much? 8 into 8 will be 64. Understood or any doubt?
No doubt, sir.
Okay. Now let's take one more condition. That is an interesting point. First of all, tell me, can diagonal element can diagonal element be 0 in a diagonal matrix? In a diagonal matrix, what do you think? Can diagonal element be 0 in a diagonal matrix? Or it has to be non-zero? Anyone? If we have a diagonal matrix, is it possible that diagonal element may be 0?
No, sir.
Anyone? Answer is yes. From the definition, it seems that diagonal element will not be 0. But the fact is, a diagonal matrix can have diagonal element 0. All the diagonal elements 0, in fact. One of them may be 0, that is also possible. But it is also possible that all the diagonal elements are 0. So if we have such type of diagonal matrix, let's say 1, 0, 0, 0, 2, 0, 0, 0, 0, at least one element at the diagonal is 0, then obviously, according to the condition, determinant will be multiplication of 1 into 2 into 0, which will give us 0. Understood or any doubt? Yes. Okay. After the determinant, we have properties of determinant. properties of determinant. First property is, if we have a square matrix A and we take its transpose and then we take its determinant. So determinant of transpose of a square matrix will be same as determinant of the matrix, which means determinant A transpose is equals to determinant A. Second property, if we have a matrix B which is K times matrix A and we want to have determinant of matrix B which will be determinant of K times A. In this case, K being a constant will be outside and this will be K raised to power order of the matrix times determinant. For example, if I say matrix B is equals to twice of matrix A is 2 into 2 order matrix and determinant of matrix A is 2. Find the value of determinant B. So what will we do is we will take determinant B, that is determinant of 2A, and according to the formula 2 is a constant value. So we will write it as 2 raised to power order of the matrix A and determinant of matrix A. 2 raised to power order of matrix A is 2 and determinant of matrix A is also 2, which simply mean that determinant of matrix B will be 2 raised to power 3, that is 8. Understood or any doubt? Yes? Any doubt? Next point is number third. If we have two matrices in multiplication A and B, and we take the determinant of these two matrices, determinant A into B will be determinant A into determinant B. Next point is determinant of any identity matrix is always 1. Determinant of 0 matrix of order n is always 0. Next point, determinant of a diagonal matrix. I already told you, if you want to have determinant of a diagonal matrix, this will be product of diagonal elements. Product of diagonal elements. Understood? Next point is very important point. If we have a matrix A, Aij of order n into n, and its determinant is 0, in that case, A matrix is known as singular matrix, and if its determinant A is not 0, in that case, matrix A is known as non-singular matrix. There will be lots of questions on this concept, singular matrix and non-singular matrix. If the determinant of a square matrix is 0, it is singular matrix, and if the determinant is not 0, then it is said to be non-singular matrix. Understood or any doubt? Let's take another point, which is already discussed, determinant of skew symmetric matrix of odd order. It is always 0. Determinant of skew symmetric matrix of even order is not 0. It may be any number. And this number has a special property, that is, this will be non-zero perfect square. This will be non-zero perfect square. Understood or any doubt? Next we have determinant of orthogonal matrix. Determinant of orthogonal matrix. So this will be either +1 or -1. Determinant of orthogonal matrix is either +1 or -1. Understood? Next point is adjoint of a matrix. Adjoint of a matrix. Of a square matrix, in fact. So if you want to find out adjoint of a square matrix, first of all, you have to work on two different concepts. One is minor of an element and another one is cofactor. So let's talk about minor and cofactor. Minor and cofactor. Cofactor. Cofactor is easy to deal with. Cofactor of any element is given by Cij will be equals to -1 raised to power I plus j, minor of that element. So to know the cofactor, we have to calculate minor. And cofactor of any corresponding element will be Cij is equals to -1 raised to power I plus j mij. In this case, I and j is the row and column, and I plus j may be even or odd. So there are two possibilities for Cij. First one is I plus j is even, cofactor will be same as minor. And if I plus j is odd, cofactor will be with minus sign of minor. Which means if I plus j is even, minor is the cofactor. You have to do nothing, just find out minor. And if it is odd, then you have to change the sign of minor. Now the question is how to find out minor. To find out minor of any corresponding element, let's say you want to find out minor of ijth element mij. This will be the determinant after deleting ith row and jth column. Which means if you have, let's say, let me write it as, there is a square matrix A11, A11, A12, A21, A22, and I want to know what is the minor of A11 element. So minor of A11 element will be given by M11, and to find out minor M11, you have to delete first row, first column. So if you will delete first row, first column, you will have A22. So minor is A22. Now, according to the minor, we can find out cofactor also. What will be cofactor? Cofactor will be same as minor, only sign will differ. So we will look at I plus j. Is it even or odd? In this case, we have 1 and 1. 1 plus 1 is 2, which is even. In case of even, there will be no change in minor. So C11 will be same as M11. Now if we have A12, corresponding to A12, we will have minor M12. To get minor M12, I will delete first row, second column. If you will delete first row, second column, you will have A21. And according to minor, we can have cofactor C12. In this case, we have 1 and 2. 1 and 2 will be odd. 1 plus 2, 3, which is odd. And if it is odd, you have to change the sign of minor. So answer will be minus M12. Similarly, find out A21. For A21, we will have minor M21. In this case, we will do what? Delete second row, first column. So if you will delete second row, first column, you will have A12. And cofactor in this case will be 2 plus 1 is again odd. So sign has to be changed. M21. A22 will give M22. Second row, second column, second row, second column will give A11 element. And cofactor regarding to 2 plus 2, which is even, will be same as minor. That is M22. Are you getting it? How to find out minor and cofactor? Yes? Okay. Now, after calculating cofactor, we have to find out a matrix which is known as cofactor matrix, and I will write it as C. C for cofactor matrix. So, what is cofactor matrix? Cofactor matrix is the matrix which is prepared by the cofactors. So, this will be C11, C12, C21, C22. This is cofactor matrix. After getting cofactor matrix, we can find out adjoint of a matrix. So if let's say this was matrix A, then adjoint of matrix A will be transpose of cofactor matrix. So adjoint of matrix A is transpose of cofactor matrix. So this will be C11, C12, C21, C22. Take its transpose, and this will give you what? This will give you C11, C12, C21, C22. Because in transpose, row will be converted into columns, and columns will be converted into row. Understood? Let's take an example. Let's say we have A is equals to 1, 2, 3, 4, and I have to write its cofactor matrix and adjoint. Again, along with cofactor matrix and adjoint, we have to find out all the minors and cofactors. So if I want to find out minor for element A11, I will write it as M11. First row, first column will be deleted. We will have 4. So C11 will be 4. A12 minor M12. First row, second column is deleted. If first row, second column is deleted, we will have 3. And cofactor in this case will be minus 3. Because 1 plus 2 is odd. And in case of odd, sign will be changed. A1, A21. For A21, we will have M21. And M21 means second row, first column, it will give 2. And cofactor 21 will be minus 2. Then we will have A22. Minor will be M22. Second row, second column deleted. We are left with 1. And cofactor will be 1 again. Because 2 plus 2 is even, there will be no change in sign of the minor. Now we will write cofactor matrix C, which is C11, C12, C21, C22, which will be what? C11 is 4, C12 is minus 3, C21 is minus 2, and C22 is 1. Now write adjoint. So adjoint of matrix A is transpose of C. This will be 4 minus 3 minus 2, 1. Am I right? This will be 4 minus 3 minus 2, 1. Are you getting it? Now, if you will look at the original matrix, this is 1, 2, 3, 4. And if you will look at the adjoint of it, you will understand that 1, 4 are interchanged. 2, 3 are not interchanged, but their sign is changed. So in case of 2 into 2 matrix, we direct have a trick to write the adjoint. And how to do it? Let's say I have a matrix B with A, B, C, D, and I want to write its adjoint directly without calculating minor and cofactor. We can simply write it as interchange A and D. Interchange A and D and change the sign of B and C. Change sign. Which means in case of 2 into 2 matrix, diagonal elements will be interchanged and non-diagonal elements will flip their sign. So the matrix will be D minus B minus CA. This is the adjoint of matrix B. In numerical terms, let's say I have a matrix A which is 1 minus 2, 3 minus 4, and I want to know its adjoint. So what will be the adjoint of matrix A? Again, what we have to do is interchange diagonal elements and change the sign of non-diagonal elements. So in place of 1, I will have minus 4. Minus 2 will be changed into 2. 3 will be minus 3. And in place of minus 4, I will have 1. This is the adjoint of 2 into 2 order matrix. Understood or any doubt in it? Yes? Any doubt? Okay. Now let's discuss how to find out minor cofactor and adjoint of 3 into 3 matrix. Concept will be same. Let's say I have a matrix A of 3 into 3 order A11, A12, A13, A21, A22, A23, A31, A32, A33. We will start from first element. So if I want to have minor for A11 element, this will be M11. And to find out the minor, what we do is we will delete the corresponding row and column. In case of A11 element, minor is M11, and to obtain the minor, we have to delete first row and first column. We have to delete what? First row and first column. So if we will delete first row and first column, we will left with determinant A22, A23, A32, A33, which will give us what? This will be A22 into A33 minus A23 into A32. And if we know the minor, we can find out cofactor. In this case, 1 plus 1 is even. So cofactor will be same as minor. Let's say we are taking 1, 2 element. For 1, 2 element, minor will be M12. To obtain the minor, we have to delete first row, second column. So delete first row, second column. You will have determinant A21, A23, A31, A33. Simplify it, and then we have cofactor C12. C12 will be minus M12 because 1 plus 2 is odd and sign will be changed. Are you getting it? How to find out minor and cofactor for 3 into 3 matrix?
Yes, sir.
Yes, sir.
Sir,
Yes, sir.
अब आंख खुल गई देखो बच्चे की 10 बजने वाले हैं ना, अब आंसर आ रहे हैं। यस सर, 4 बच्चों ने आंसर दिया। मॉर्निंग के टाइम नींद आती तुम लोगों को है ना, मैं अकेला बोलता रहता हूँ। देखो यस सर बोल रहा हर जी। ओके, So now we are left with nothing. Adjoint is completed. What you have to do is find minors, corresponding cofactors, then design cofactor matrix and take its adjoint. Adjoint of a cofactor matrix will give, transpose of cofactor matrix will give adjoint. After getting adjoint, you will be try to find out A inverse. A inverse is given by adjoint A divided by determinant A. Now in denominator we have determinant. So first of all, let's understand what is the role of determinant A. There are two possibilities, either this is not 0 or this is 0. If adjoint A is not 0, then there will be no problem for A inverse. This will be adjoint A divided by some finite value. Or in other words, we will state it as A inverse is 1 upon determinant A times adjoint A, which means we have to multiply 1 upon determinant A into the adjoint matrix. And to multiply a matrix with a scalar, the rule is that you have to multiply the scalar with each element of the matrix. So we will multiply 1 by determinant A with each element. But this will be possible only if determinant A is not 0. By chance, if determinant A is 0, then this will be a matrix multiplied with 1 upon 0. 1 upon 0 will be infinity. And everything will be infinity, which is senseless in case of matrix. Because matrix is a arrangement. And arrangement cannot be infinity. It has to be something. So there are two cases, either determinant is 0 or it is not 0. If it is not 0, we state that A inverse is possible, or let me write it as A inverse exists. In this case, A inverse does not exist. The matrix for which inverse exists are called invertible matrix. Invertible matrix. And the matrix for which inverse does not exist is non-invertible matrix. Non-invertible matrix. In other words, we can also state that if A is a singular matrix, if A is a singular matrix, then its determinant will be 0, which means it will be non-invertible. Another case is if it is non-singular, then determinant will be non-zero and its inverse will exist, and this will be known as invertible matrix. Next point is, if we have two matrices, obviously square matrices A and B, and these two matrices are such that A multiply B is defined, B multiply A is also defined, and the multiplication is I. A multiply B is I, B multiply is also I. Identity matrix. In that case, we say that A is the inverse of B, A is the inverse of B, and B is the inverse of A, which means A inverse is B and B inverse is A. Are you getting it? Are you getting it? फिर से सो गए क्या?
Yes, sir. Yes, sir.
No, sir.
Okay, so determinant is completed almost. In the next section, we will complete and do the questions. Now, we are left with only one thing, that is general aptitude. Okay. In general aptitude, we will do an interesting topic that is known as time and work. General aptitude. Topic is time and work. Time and work. There may be different type of question in this topic. It may be easy, moderate, or difficult. The core concept will be same for all the questions. Core concept will be same for all the questions. What is the core concept? The concept is there is a person which can perform a work or which can complete a work in certain number of days. There is another person which can complete the same work in certain number of days. If both of them start the same work at the same time, then in how many days the work will be completed? This type of questions will be there in time and work. And the concept is same. You have to consider work as one. If work is completed, it will be taken as one. If work is not completed, it will not be one. It will be fraction of one. For example, if work is half completed, it will be 1/2. If work is completed 25%, this will be 1/4. If it is completed how much? 50%, this will be 1/2. So the concept is, first point, if A can do a piece of work, if A can do a piece of work in n days, then A's 1 day's work will be what? So this will be 1/. Second point, if A do 1/n work in 1 day, then A will take n days to complete the work. To complete the work. Are you getting these statements? If A can do a piece of work in n days, then work done of A for 1 day will be taken as 1/n. If in 1 day A do 1/n work, then to complete the task, he will take n days. Are you getting it? Second point is about efficiency of two persons. Let's say we have two workers, A and B, and worker A is far more efficient than worker B, or in simple words, worker A is more efficient than worker B, which means worker A can complete the same work in less number of days as compared to B. For example, A is thrice as good as B. A is thrice as good as B. Then ratio of work done by A and B. Ratio of work done by A and B will be 3:1 because A is 3 times more efficient than B. And if you are looking for the time, ratio of time taken by A and B to complete the work, because A is more efficient, so obviously it will take less number of days. In that case, this will be 1:3. Are you getting it or any doubt?
No doubt, sir.
Okay. So this is the only concept. If a person can do a piece of work in n days, then for one day we will take 1 by n part of the work which will be completed by the person. And if one day's work is given to us, we can find out the number of days in which work will be completed. Let's do some questions so that you can understand how to apply the concept. Question is, if user can do a piece of work in 8 days, and Antonic can complete the work in 5 days. We are talking about the same work. Can complete the same work in 5 days. Question is, in how many days will both of them together complete the work? Are you getting the question? There are two persons, A and B. A can complete the work in 8 days. B can complete the work in 5 days. Now the question is, if they work together, in how many days work will be completed? So we can solve it as A complete the work in 8 days. So 1 day's work will be 1 by 8. B complete the work in 5 days. So 1 day's work for B will be 1 by 5. This indicates that B is more efficient than worker A. Now they work together. So if they work together, how much work will be completed in 1 day? Together, work completed in 1 day. Work completed in 1 day. Work completed in 1 day will be work done by A plus work done by B. A has done 1 by 8 and B has done 1 by 5. Simplify it. What will be 1 by 8 plus 1 by 5? This will be how much? 8 into 5 now. 8 plus 5 will give 13 by 40. Right? Which means together in 1 day, this amount of work is done. If you will reverse it, 13 by 40 work is done in 1 day. So in what time one work will be done? I already told you, complete work will be taken as 1. So 1 unit work will be done in 1 upon 13 by 40. That is 40 by 13 days. Right? Now you need not to do this again and again. You have to remember it as a fact or as a point. What is the point? If you have total work done of 1 day, then reciprocate it, you will get the number of days in which work done will be completed. Are you getting it or any doubt?
Yes, sir.
Okay,
No doubt, sir.
40 by 13 means 3 and 1 by 13, which means if A and B both work together, then it will take 3 complete days and 1/13th part of the day. 1/13 part means, if you will convert it into hours, you will understand the sense. 1 day means 24 hours. Then this will be what? 24 divided by 13. which will be 13 times 2, 26, approximate 2 hours, which means to complete the work, 3 days will be taken completely, and there will be 1.8 hours, which will be taken from the next day. Are you getting it?
Sir,
Yes.
can you explain again why do we reciprocate that?
Okay. The reciprocal is done in this sense because we have calculated work done by A and B in one day. So this will look like in one day, this amount of work is done. Now I will write it in reverse direction, which is 13 by 40 part of work is done in one day. But I do not want to complete 13 by 40 work. I want to complete the whole work. And complete work is taken as one. Right? So 13 by 40 unit is done in one day. I want to know how much time it will take to complete one unit. So for one unit, we will write it as 1 by 13 by 40. It is simple mathematics, class 8, 7. टॉफी वाला हिसाब है ना ये कि 15 टॉफी 20 रुपए की आती है तो एक टॉफी कितने की आएगी. सिंपल कैलकुलेशन है. So 13 by 40 unit is done in one day. So one unit will be done in 1 by 13 by 40, which will give 40 by 30. So what I am saying is that you need not to do this calculation again and again because it is going to be same in all the cases. What is the concept? We will calculate the work done in one day and then we will reciprocate it. So we will get the number of days. Understood?
Yes, sir.
Yes, sir.
Let's solve one more question, which is same. A and B together can complete a piece of work in 15 days. In this case, A and B are working together. So A and B, if work together, they will complete it into 15 days. Which means 15 days are taken by A and B together to complete the work. B alone can complete it into 20 days. If B is working alone, he will complete it into 20 days. You have to tell how many days will be taken by A to complete the work. So remember, in all these type of questions, time and work, whenever you have to do the calculation, you have to do calculation in reference of one day. In this question, we are given 15 days and 20 days, right? So first of all, we will convert this question in terms of one day, and then we will solve the question. Which means if A and B are working together, they take 15 days to complete the work. Which means in one day, A and B has done 1 by 15th part of the work. Yes. If A plus B are taking 15 days, so one day will have how much? 1 by 15. Now, one day for B will be completed by doing 1 by 8 work. Sorry, 1 by 20. 1 by 20, understood? So now you can say that 1 day work of B plus 1 day work of A is equals to 1 day work of A plus B. Am I right? 1 day work of A plus B is what? 1 day work of A plus B is 1 day work of A and 1 day work of B, right? And here we have 1 day work of B as 1 by 20 plus 1 day work of A, let me write it as A, is equals to 1 by 15. So A will be how much? 1 by 15 minus 1 by 20. And I think 1 day work of A will be, LCM will be 60. This will be 4 and this will be 3. So 1 day work of A is 1 by 60. Now we know the work done for 1 day and I want to know the number of days. So I already told you just reciprocate it. So number of days taken by A to complete the work taken by A to complete the work will be. Understood or any doubt?
Clear,
Yes.
sir.
Okay.
Sir.
Let's take another question. In this question, we have three different workers: worker A, worker B, and worker C. A took 5 days to complete the work done itself. B take 4 days to complete the same work, and C take 20 days to complete the same work. If A, B, and C both work together, in how many days work will be completed? So if A, B, and C all are working together, how many days will be taken to complete the work? Again, to calculate the total number of days to complete the work done, we have to find out work done in 1 day, right? All the questions in this chapter will be done with reference of 1 day. So you have to convert the question into 1 day form and then do the question. So if A, B, and C are working together, let's calculate how much work will be done in 1 day. If A took 5 days to complete the work, so A's 1 day work will be 1 by 5. Similarly, B's 1 day work will be 1 by 4. And C's 1 day work will be 1 by 20. So work done in 1 day by A, B, and C will be 1 by 5 plus 1 by 4 plus 1 by 20, which will give us what? Multiplied by 4, multiplied by 5. So this will be 4 by 20 plus 5 by 20 plus 1 by 20. Denominator is same. You can add numerator, which will give 4 plus 5 plus 1, that is 10. 10 by 20. So in 1 day, 10 by 20 work is completed. That is 1 by 2. So number of days will be how much? Number of days. Reciprocate it. It is observable. If half work is completed in 1 day, then the remaining half will be completed in the next day. So total 2 days will be taken to complete the work. Are you getting it or any doubt? Yes? Understood?
Yes, sir.
Let's take another question. It's little bit complicated. Question is, A can do a piece of work in 7 days of 9 hours. तो A जो है वो 7 दिन काम करता है. A works 7 days and in 7 days he works for 9 hours each. 7 days of 9 hours. B did the work for 6 days of 7 hours. 6 days of 7 hours. Question is, how much time they will take to complete the work how much time they will take to complete the work. So in this question, worker A and worker B are not working whole day. They are working only 9 hours a day and 7 hours a day. So we will convert the question into number of hours. So let's find out total number of hours work done by A. So 7 days, 9 hours each. This will be 63 hours. For B, this will be 42 hours. What will be the work done of A for 1 hour? A's 1 hour work will be 1 by 63 and B's 1 hour work will be 1 by 42. If they work together, what will be 1 hour's work? Together, 1 hour's work will be 1 by 63 plus 1 by 42. How will you solve it? 1 by 63 plus 1 by 42. Yes? 1 by 63 plus 1 by 42. What will be the LCM? This will be
2, 4, 5.
this is 7 into 3 into 3. And this is 7 into 3 into 2, right? So let's take 1 by 7 into 3 outside. 1 by 21. We are left with 1 by 3 plus 1 by 2, which is far more easier to solve. This will be 1 by 21. This will be how much? 5 by 6, I think. So this will be 5 by 126. So 1 hour's work is this much. So how many hours will be taken by A and B together to complete the work? Reciprocal of this will be how much? This will be 25.2, which means 25 days complete and 2 hours. Sorry, number of hours है ना? So 25 hours complete and 2 hours extra. 2 hours नहीं, गलत बोल रहा हूँ अभी. 25 hours complete and 2 minutes extra. Now, if in the same question there is third condition, and condition is like this: if A work 7 days of 9 hours each, and B can complete a work in 6 days of 7 hours each, then how much time will they take to complete the work done if they are given together 8 and 2 by 5 hours? They are given together 8 and 2 by 5 hours. So in this case, we are taking total number of hours as
Sir, can you repeat the question?
126 by 5. 126 by 5. And I want to know the number of days to complete the work if both work 8 and 2 by 5 hours each. 8 and 2 by 5 hours will be how much? 42 by 5 hours. Yes? So if they work 42 by 5 hours, it will be 1 day work. For 1 hour, this will be 1 by 42 by 5, that is 5 by 42. And for 126 by 5 hours, 126 by 5 hours, this will be 5 by 42 into 126 by 5. 5 factor will cancel out, and 42 divided by 126 will be how much? 3 days. So 3 days will be taken by A and B to complete the work complete. Whole work complete together. Understood or any doubt?
Sir, can you please repeat the previous one?
Last one? Or the complete question?
Sir, complete question.
Okay. So in this question, we are given with two workers, A and B. Worker A, if only worker A work, he will take 7 days to complete the work when he work 9 hours per day. If it is worker B, he will take 6 days to complete the work if he works 7 hours a day. Now the question is, how many hours will be taken by them together to complete the work? This is one part of the question. And another part is, how many days will be taken to complete the work if they work together for 8 and 2 by 5 hours per day. So we will divide the question into two parts. First part is, let us find out total number of hours will be taken by them to complete the work. For that, we will have to convert the question into number of hours, because this question is given in days and hours. So we will simply convert it into number of hours. Let's say A work for 63 hours total and B works for 42 hours total. So A's 1 hour work will be 1 by 63 and work done by B in 1 hour will be 1 by 42. If they work together, then A plus B's work done for 1 hour will be 1 by 63 plus 1 by 42. On simplification, it will give 5 by 126. So total number of hours taken by A and B to complete the work is 126 by 5. If they are asking about total number of hours, answer will be 126 by 5. But if they are asking find the number of days to complete the work done by A and B together, if they work 8 and 2 by 5 hours per day. So now I will relate it with the number of days. Question is, they work for 8 and 2 by 5. They work for 8 and 2 by 5 hours per day, which simply means is that 42 by 5 hour will be considered as 1 day. Right? If we have done 42 by 5 hour, our work will be completed, or the work of the day will be completed and we will take off. So 42 by 5 hour is taken as 1 day. So 1 hour will be taken as 1 upon 42 by 5, that is 5 by 42 day. And we are working total 126 by 5 hours. So 126 by 5 hour will be equivalent to 3 days. 5 by 42 into 126 by 5. So total 3 days will be taken by them to complete the work. Understood or any doubt?
Understood, sir.
कर क्या होना नाश्ता? मैं जाऊंगा ना, अब लेक्चर ऑफ होने के बाद जाऊंगा। भाई यहाँ तक करना है आप लोगों को। ये पीडीएफ की रिक्वायरमेंट होगी क्या?
Yes, sir.
Yes, sir.
ये मीटिंग में ही शेयर कर दूं, मैं डाउनलोड कर लोगे क्या?
Yes, sir, कर दीजिए. सर एप्टीट्यूड में नेक्स्ट टॉपिक क्या रहेगा?
क्या?
एप्टीट्यूड का नेक्स्ट टॉपिक.
टाइम एंड वर्क के बाद टाइम एंड डिस्टेंस, अप्रैल 7।
Sir, this PDF will upload on Drive.
ड्राइव पर अपलोड करनी पड़ेगी क्या अब? अप्रैल 7। ये तो सेव ही नहीं हो रहा। हो गया। चेक करो, पीडीएफ आएगा एक, चैट बॉक्स में चेक करना। किया क्या डाउनलोड?
Yes, sir.
Yes, sir.
व्हाट्सएप भी करूं?
No need.
नेक्स्ट लेक्चर में मिलते हैं फिर।